Hello, everyone. Good morning for me, at least. Good afternoon, I think, for you, Sandro, and good evening, good wherever you are in the world. Welcome to another Believe in Serverless live stream. I'm super excited for this week's talk because I've never used GraphQL, and I'm excited to learn how Hashnode use it. But before we get into that, let's just talk about what we've got coming up next week on Believe in Serverless. On Tuesday and I'm going to give you all these times in BST, sorry for anybody listening who's not in BST. On next Tuesday at 2 o'clock BST, we have a fireside chat with Juan Garcia talking about healthcare provider burnout and Gen AI. So that sounds cool. If you're interested in all this Gen AI buzz going on at the minute, then that'll be an awesome talk for you. And then we've also on Thursday next week got Chris Price talking about lesson learned using gRPC in production, which is another super cool talk because that's something else I've never used in production like today's technology. So I'm super excited to welcome Sandro Volpicella. Hopefully my British accent doesn't absolutely murder that. Sorry, Sandro. How are you doing today? Are you all good?
I'm very good. Thank you. How are you?
Yeah, doing all right. It's like I said, we were saying just before we came live that we're finally starting to get something like a summer in Britain. So I'm feeling particularly excited today. So yeah, Sandro, I'm going to hand things over to you. For anyone listening, watching, however you are consuming this, drop some questions in YouTube, in Twitch, wherever you are. I can give them to Sandro right at the end. But Sandro, I will hand it over to you if I make your screen appear. And enjoy, everyone.
That's amazing. James, thank you so much. Really appreciate the invitation. Really appreciate what you do for the community. I know how hard it is to run such a Discord community or community at all. So I love to follow all the discussions you have and Believe in Serverless and try to participate as well. So love to do that. Thank you. My name is Sandro Volpicella. I'm talking today about Hashnode's journey into its public GraphQL API. And I want to focus especially a lot on giving you some real-world experience and some lessons learned from a perspective of mine, from, I would say, not a GraphQL pro at the beginning, and looking at how Hashnode built the API and what we've learned there. So let's get started on that. First of all, who am I? So my name is Sandro. I am a software engineer. I call myself a full-stack serverless engineer, so I build a lot of things on AWS, work a lot with the typical AWS services, but I also touch the front end once in a while, mostly with React and Next, and I also have a small remix project, so I like to do it as well. I'm from Munich, so I live in Germany. You probably know Munich either from the Oktoberfest, which starts in 2 months again, or from our infamous football club. I work as a platform engineer at Hashnode since about 2.5 years, so started at the beginning of 2022. And platform engineering, I want to say, is quite different in a startup if I compare it to where I worked in enterprises. So we still try to give a platform to our core developers with like the best golden pathways, I always say, but we still do lots of hands-on things, do lots of feature implementations, and I love that about the role. I'm also an AWS community builder, so I try to create a lot of content about AWS. For example, I have the book awsfundamentals.com, and I'm currently creating a course and a book about CloudWatch. And in my leisure time, I love to play tennis and lift weights. I think that's mostly about me. So this talk will be about GraphQL and Hashnode's journey. So in the next 30 to 40 minutes, I first start on to give you some context on what Hashnode actually is. Then I show you the starting point. So when I started, how did our architecture look like? Why did it look like that? And especially, why did we choose to build a central API and a public API? Then I want to give you some introduction to GraphQL and tell you why we chose GraphQL over simple REST API. And then we go into the how. So how did we implement it? How did we implement it in a serverless way? How do we do edge caching on the edge? And as a final slide and as a final recap, I want to give you some lessons learned, what I've learned with GraphQL, what I've learned with building a public API and all stuff around that. So first of all, what is Hashnode? If we would be in a room, I would actually ask you to raise your hands if you know Hashnode. Since we can't do this, if you want, you can put it in the chat. If not, I introduce you anyway to it. So Hashnode is a developer blogging platform. And one thing we value a lot is that you can focus on your writing. We don't want you that you need to create any starter kit, deploy anything. You can simply go to Hashnode. You can connect your custom domain. This is really one of our major features what everybody loves. For example, my blog runs on blog awsfundamentals.com, and you can start creating your content. And we focus a lot on having a really good editing experience. So we have an editor, you can see it here on the left side. We have a Markdown-based editor. After some months, after 2 years of Hashnode, we've built, and what you see is what you get editor as well, so that non-dev heavy folks can use it as well. And we try to make your editing experience very nice. We have image uploads, we have AI features, we have a research sidekick. So you can really get started creating your content from minute zero. This is what we want to do. And some additional features, like we have a newsletter, so you can send out your blog posts to subscribers, create a community. We have webhooks, which are actually built with step functions. We have a GitHub backup, because we also want to give you the opportunity that if you don't want to use Hashnode anymore, that we are sad, but you still can go export everything to Markdown and go to the platform of your choice. One more enterprise feature that we recently launched is our Headless CMS. And I mentioned this because this is one of the main reasons why we've built the API. We had many enterprises who used Hashnode more on a private basis and wanted to introduce Hashnode also into the companies. And enterprises just need a bit more flexibility that we could offer. So this is why we also offer Hashnode as a headless CMS. That means you hook your frontend into our APIs, make use of all the caching of the editor and everything like that. So that's all about Hashnode. I now want to give you some context about starting with an API mess. That's what I call it, at least. So I want to show you how the architecture looked like when I joined Hashnode. And you can see it's not a huge architecture. It's like just 3 bounding boxes, but we know that a lot of details can hide behind these boxes. And I want to give you a broad overview of this whole architecture, so I go step by step a bit through it. Let's start with Vercel. I'm not sure if all of you know what Vercel is. Vercel is called as the front-end cloud. So they are also the makers of Next.js, which is a Meter React framework, which also takes care of some backend functionality. And we have our front ends, our Next.js servers deployed on Vercel. So first of all, we have our front end deployed on Vercel. Then the front end, especially the blog posts, are server-side rendered. That means there is some server in the background, some Lambda function, for example, and we can server-side render these blog posts. We get HTML as a response, and the user can see the whole blog post. But then we also have API functions. There are always some client-side calls, so we have API functions. On Next.js, in the old pages router, it was typically you have a file in pages/API/file, and then you have your API route in there. For those of you who use Lambda, it's pretty similar to a Lambda function route. Then all of this needs to be powered by some data store. So first of all, we have Next.js. What I forgot, Next.js is SSR is also using these API functions, of course. So if you need to server-side rendering something, we call APIs, and then these API functions are used. Then we have some data store. For us, this is MongoDB Atlas. This is the main data store. We have some more data stores, but mainly we use MongoDB Atlas. The API functions need to consume data, so of course we get data from MongoDB. But at the same side, server-side rendering also needs to get data, and also, unfortunately, picked to have direct access to this database, so we get data from, like, not just in server-side rendering, but also in the API functions from MongoDB. And to make things a bit better, we also have a legacy API. So we have an API which is in an AWS account, and we are one of the few customers of the service Lightsail. So we have a monolithic Express API there, and our old public GraphQL API, not going to talk a lot about that. And they also get data from MongoDB, of course. And now to make things a bit better, we had these Next.js API functions sometimes needed some complicated aggregation pipelines, some old data which was only available on the old API. So we called this API. Same thing happened from server-side rendering. We also called this API. So you see it gets a bit more complex. And I think the tipping point when we've decided, okay, it gets a bit too much, is when we've introduced a mobile application. The mobile app, of course, also needs to be powered by something. And this is by API functions, and on the same side on with our legacy API as well. So this was the state when I joined Hashnode. And this was one of my major works, and this is also why we get hired in startups, to make things better and to make things more performant. So some of the obvious downsides we have here are the business logic is completely mixed with the data access. So if I look over server-side rendering, for example, in server-side rendering, we have some business logic to get some data, to compute this data, but it's not in any APIs as well. So the data access is completely mixed with the data, with the business logic. And then we also had duplication of API and implementations. So if you think about, if I do something in server-side rendering in a function, but I also need it in my app, I also need to duplicate the whole thing into clients, into the API. So I also need it over there. So we duplicated lots of things. The caching is quite hard, and caching, you will see it throughout the presentation, is quite an important topic for us because we have long-lived content. So the caching on server-side rendering was not really possible because back then you could only cache it for a certain amount of time. And Next.js didn't have any option to do it otherwise. That means you cache it for like 15 seconds, but if the title is changed right after publishing, the user needs to wait for 15 seconds. So that wasn't really good. And we didn't have any standardization. And I think this was also developer experience-wise the main part. Authentication was done differently every time. We couldn't share any types because our whole company runs on TypeScript, and observability was really not given. So we wanted to build a central API. This is kind of the repetition of what I just said. Why a central API? We have different clients. We wanted to have standardization. We wanted to have caching. And if you look at caching, all incidents we had back then were due to a high load on some uncached fields. And caching is not just a performance issue, but it's also a high security issue for us because MongoDB is not well suited for a serverless environment, I would say. And if the connections hit the maximum, for example, we always have some incidents, and they were 90% on caching. So we wanted to focus on that a lot. So we decided to build a central API. But next, why did we want to build a public API? First of all, our business or our API is nature in public. So we are a blogging platform. So if somebody posts a blog post, we want to have it public. If it's on Hacker News on page 1, we want it, everybody can see it. You shouldn't register for that. That doesn't mean that the API needs to be public, but it means that our content in our business is public in nature. And we want to give developers, which is our target audience, also the freedom to build integrations. And we had some great integrations. For example, we had Alan Helton, who created the whole Believe in Serverless community, I think, built the serverless cross-posting. So like an open source mechanism, how you can cross-post to Medium, Hashnode, and so on. Then we had Andrea and Pascal, who both worked for AWS, who've built a semantic search and actually won our hackathon. Or we have Binaya, who built Hashmind, a blogging assistant where you can talk to your blog posts and create blog posts like that. So we saw that we have really good integrations built like that, and that we see more and more of that integrating with Hashnode. And this is only possible because we have good APIs. And the major factor really is we want Hashnode as a headless CMS. And having good APIs is really the basic block for that. So I think that's enough about Hashnode and why we want to have a central API, why we want to have a public API. Now let's talk about GraphQL a bit. In the Believe in Serverless community, I know that Andrea and especially Benoit made an introduction to API Gateway and AppSync. So in case you saw this already, it's kind of a repetition. So let's talk about an introduction to GraphQL first. And the main thing about GraphQL are operations. So we have 3 kind of operations we always do. This is queries. So we want to query some data. For example, here I want to have the user with the username Sandro, ID, username, and the bio. So pretty similar to GET requests. Then we have mutations. This is for mutating data. In this example, I want to publish a post and return the post ID and slug. So you can compare that to post, put, delete requests. And then we have subscriptions. Subscriptions are real-time WebSocket notifications if something happens. For example, here, if a post is published, I have a subscription. We are not using subscriptions at all, but we are mostly using queries and mutations. But these are the three things we have in GraphQL. The next part we have is a schema. And that is one part about GraphQL I really like, is that we have a schema definition about what the API is offering you. And this is also quite different to REST, because in GraphQL, you actually start with a schema. So you need to define a schema, which data you can query. And in this part, this is part of our schema of a blog, so of a publication. Here you can see that we have different fields. So we have a field about of the type content. We have a field drafts. We have a Boolean if this is a team publication or not. We can see if it's pro or not. And the cool thing about these fields is that each of these fields can be resolved by a so-called resolver. And a resolver is a simple small JavaScript function, which is the only responsibility of this function is to resolve this one field. And what we can see is that all of this data comes from different data sources. So the about content, for example, is simply saved in MongoDB. The drafts are saved in Firestore. The Pro subscription is saved in Stripe. And for example, our scheduled drafts are event-push schedules. And the cool thing with having these small resolvers is you can choose the data source where it's coming from and simply define a very small function to resolve these fields. And of course, this is also possible with REST. Don't get me wrong, you can also have an endpoint which talks to the Stripe API. But having these small resolvers based on one level makes readability and maintainability, in my perspective, really, really easy and really good. There's a great talk about that with some cons from Primagen. If you have too many resolvers, too many promises, garbage collection, it can get really bad. But I think that goes a bit too deep into that. But the main thing is you have a schema, you have resolvers, and small functions that resolve this data. Then one thing or one difference from GraphQL to REST is in GraphQL, you only have one endpoint. And if we look at a typical REST example, we see we have multiple endpoints here. We have one endpoint to get the post preview of a CloudWatch post. Then we have a second endpoint to get the full post of a CloudWatch post. And the third endpoint to get some publication metadata about that. In GraphQL, this is quite different. We have one endpoint for that. And this endpoint only accepts post requests. And the client here chooses the data he wants to have from this endpoint. We will see this later on as well. So the GraphQL, we have one endpoint, we have fewer network requests, which doesn't need to be a good thing because we have pretty large network requests, but we have a much simpler observability. So I think so much about the intro to GraphQL. I think that should bring us all on one common ground about what GraphQL is. But why did we choose GraphQL over REST? Because we already had a REST API, right? One thing about that is the actual graph. So I think each application, each organization has relational data. So we always have relations in our data. But if you look in our data, and I think blogging is a typical example for GraphQL API, we have a publication, and a publication can have posts. A post on the same time can have one or more authors. An author, again, can have a post or can have publications again. And the publication can have posts again, and so on and so forth. So it happens a lot that in our web applications, we traverse this graph multiple times. Because if we want to show a blog post and we want to show the user and the author of this post, and then we hover over this author and we want to show related blog posts, or we have a tag and we want to show related tags, all of that is data within the graph. And the cool thing here is that the user, the front end, the client can simply choose which data to get from the backend. So if we take this example here, and this is what a GraphQL query looks like, and we want to get posts for a certain publication. So we want to get the posts for my blog. And now we have the ID, we have the title, so some metadata about the blog, and then we have the first two posts. Once we execute that, we can see that we get a huge JSON blob and we get two posts. We get some data about the publication and some data about the author. And if you want to map that now to our graph, we can see it here with the color. So we can see in red, we have a publication. In green, we have our post. And in blue, we have our author. And if now the client decides he needs more data, he can simply change the GraphQL query and has the tags, for example, as well. So this is the main part. We have graph data. And we also want that the client chooses the data. I kind of spoiled it already to you. So if you look at that, here you can see a typical screenshot from our homepage. So this is my blog, for example, and the GraphQL query that powers this page. I conquered it a bit, so because it would be too large. But if you look at that, we simply get some metadata for the publication. So we need to show social links, we need to show the navbar. But I also get the first three posts here. So with the description, with the image and stuff like that. If I want to show the full page now, so this is the full page, I simply get the full post with the content markdown and some other stuff, and all the other rest it can stay the same. So we don't need to implement any other endpoint for that. We simply choose the data we want and we get it into our client. If we compare these two things, we have exactly the same two queries, except that we once get posts, so which is a list of posts, and we have once the single post, which has the full post with the content markdown. So the second reason is really the client chooses the data. We don't want that the client goes back to the backend team or needs to go to the backend, implement another API just because we now need the content or we now need one more flag. So with GraphQL, the client can choose the data he wants. And the last part, I try to summarize it a bit to not talk too much about the basics, is the playground, the observability, and the type safety. So first of all, each GraphQL endpoint, if you enable it, has a playground. And the playground is kind of a live documentation and execution environment. That means if you can go to gql.hashnode.com, you will see our playground here, and you can execute requests. You can see inputs for mutations. You can see which fields are available for users. So all of that is available in the playground. We have very good observability in GraphQL. We can see the errors by types and by users. We can see lots of things and have insights how people are using our API. And we have a type safety, which was pretty important for us because with CodeGen, we can generate our types depending on the queries that are used. For example, we can even generate whole SDKs out of the queries and mutations that are used in our code base. So we have a type safe access to that. And this is worth a lot. So they have a small TLDR on that. Hashnode's data is a graph. This is why we use GraphQL. We want to have the same data structure represented on our API as well. The client chooses the data, and we want to have a centralized data access. It is automatic documented with the playground, and it's much more user-friendly and especially developer-friendly in my perspective. It's type-safe, and the observability is much nicer. So how did we implement the whole GraphQL API? And I think the main part about our architecture is that we didn't use AppSync. And I know Michael and Benoit are maybe not too happy about that, but we have some reasons about that. I'll show it to you in a second, but let's first go to our architecture. So our architecture is pretty simple, to be honest. We have a user on the left side. The user hits our cache. We have a Stellate cache. So Stellate is a company. I introduce you in the next section. But basically, it's a CDN which caches GraphQL responses. Then it hits, if it's a cache miss, then it hits our AWS account. And in AWS, we use an API gateway, which has an integration with Lambda. Lambda is quite large because we use Apollo GQL in here. And then it talks to MongoDB or to all our other data stores. In the Lambda, we make use of EventBridge. Our whole architecture is based on an event-driven architecture. So we emit events, and then we purge the cache based on the events if it's not automatically purged. All of that is based on infrastructure as code, of course. We use SST and CDK for that. And I show you some things about CDK and SST as well. So let's talk about why didn't we use AppSync. First of all, the team who created the API, I was also a core member of that, was familiar with Apollo. I used AppSync in the past. I like AppSync, but the team was simply more familiar with Apollo at that time. And our old API was also built on Apollo. Then one part about AppSync, which is not too good, is that it doesn't have an executable schema. So that means the schema, the SDL we saw earlier, is simply a huge blob of string, which we put into AppSync, which can have some annotations, but we can't use anything of that. So we can't make use of custom annotations, which we use, for example. Then there were some gimmicks with AppSync, which were annoying for me. and also annoying to explain in the team why we needed to do that, because we wanted to have a public API. But as most of you who build APIs on AWS probably know, there is no such thing as a public API in AWS. You need to have an API key. And yes, there are workarounds, but still it is not supported by default. And that was also already a reason which was a bit annoying for us. And then we have authentication mostly in cookies. And back then, it wasn't possible to have the cookie in the request. So we couldn't do any authentication as well. We could have done it with another workaround, but this would be workaround 2 with a lambda@edge function. This is also now changed, so it's not an issue anymore, but this was an issue. Then we don't need any direct integrations. What I love about AppSync is we have direct integrations to DynamoDB, to step functions, and to all of these great services. But our data store lives on another system, which is Atlas. So we didn't need any direct integrations. We had a Lambda anyway in there. And if we would need these direct integrations back then, again, we needed to work with VTL. And I'm not sure if you've worked with VTL. If you try to show it to somebody who's not familiar with it, it's not the best developer experience. So it's pretty hard to build and to debug. And I think in the end, the main reason why we use Apollo now and why we've decided for Apollo is it is quite nice. So don't get me wrong, it's not no AppSync and we just picked something else. Apollo has really nice features. There's a huge community, huge open source community, and lots of plugins, content around that. I think they even have their own GraphQL summit. So this is why we used Apollo. And I now want to show you some of the nice features Apollo offers. For example, executable schemas. I said that before. What that means is we use annotations in here. So for example, we have @constraint. Constraint is a validation of some input here. So we have a constraint for if you want to publish a post, we have a title, and this constraint is minimum length 6, maximum length 250. I don't need to explain it to you because you can see it. And this is the main reason why it's that great. So you don't need to look at any code. You don't need to look at any middlewares, MIDI middlewares or anything. You just see a constraint on the schema level and you understand what is allowed and what not. We can use regex here for a slug. We can say, okay, this is the canonical URL. It needs to be an URI, or an array is only allowed to have maximum 4 items. So that's really nice. And we also use annotations for requiring authentication. I told you earlier that a downside of the architecture of our old architecture was that authentication was done differently all the time. But here we can require auth, that means user needs to be authenticated, and we can give him some scopes. So is he allowed to write a post? Is he allowed to write a series? Is he allowed to update the post? And you look at that, you read it, and you understand it. And this is what we want with code, right? So that's pretty nice about Apollo. We have some more things in Apollo, like we have custom logging plugins. We can hook into the life cycle before a request is sent, before response is sent, when error happens. We can hide parts of the schema because we don't want everything to be public. So there are many things you can do, which I don't think you can do with AppSync. So this is why we chose to use Apollo. But since we use Apollo in a Lambda function, I think the elephant in the room is what is about cold starts. So let's talk about cold starts. Our bundle size, our package size is bad. So we have 4 megabytes of our Lambda function, which is quite large. But the main thing here is how often the cold starts really happen. Fortunately, we have lots of traffic, so our API gets lots of requests, and the number of cold starts is quite low. So you see that we have 0.05% of cold starts. And this is not 5%. I already multiplied it by 100. So this is 0.05% of cold starts. That means we don't have many cold starts. And to give you another overview, sorry for the bad resolution, but I wanted to prove that this is coming from CloudWatch. So we have our daily cold starts here and our daily requests. And as you can see, we sometimes have peaks of cold starts. Then we have 0.1%. And we have over 1,000 cold starts a day. And sometimes they are bad. So 700 millisecond is, of course, not a great experience. But they still happen in perspective of how many requests we do, not a lot. And especially for our important part, so for serving out our blog posts, we use so much caching that our experience is always for the end user mostly great. We try to improve this anyway, but this is not a huge focus. And this is also something always to think about when you want to improve cold starts. So try it out in production, look at your numbers, and the benefit we have by using Lambda and by having the scaling is outweighing the cold starts we have, in my opinion. Then let's talk about SST a bit. SST is called Serverless Stack. It's an abstraction on top of CDK, or it was an abstraction on top of CDK. Future versions will work more with Pulumi and Terraform, or with Pulumi. And the live Lambda development is quite nice. So what the functionality is doing for you is you deploy your API gateway, you deploy your Lambda function. But if you are in a production, and if you're in the development environment, so you have SST started, you're actually not deploying your Lambda code, but you're deploying a stub. So that means once you send a request to your API gateway and the API gateway sends it to Lambda, there's no code in the Lambda that is executed. It will be actually sent to your local PC via WebSocket connection, and then your local code will be executed. What that means is there is no hot swapping, there is no deploying going on in the background. You simply save your local code because your local code will always be executed. So this is a really nice developer experience. That means no different configuration for localhost, because we tried that first with pure CDK, but then you need to pass the events in different ways for Apollo that localhost is working, and that's kind of annoying. We don't need to mock any APIs because IAM is working, or because all of the APIs are working, because we run in AWS, and we could even set breakpoints in Lambda. We do have some downsides, so it's still not a full simulation. So it runs on your local PC. One thing we saw is CloudWatch EMF metrics. So if you log in the EMF format, for example, and you want CloudWatch to pick up these logs, it can happen. It won't happen in the end because you log to your local machine. So this is something to be aware of, but to be honest, this is the only example I can give you of that. And the second thing is you have dependency. So you have CDK, which is from AWS. You have an abstraction on top of CDK. And I have no idea what happens if, I don't know, Dex goes full in coffee business and now leaves SST, and no idea what happens then. But you always need to live with these dependencies. We also see that now Iron is out there, so the whole thing without CDK. And I've heard in the podcast that there will be no proper migration path, so I'm not 100% sure what happens once we do this. But it's still the best trade-off in terms of developing an API locally by far. If you have a better trade-off, which is kind of based on CDK, let me know. I'd love to try it out. So that's all about our architecture. Let's now talk about edge caching, because I talked you through our whole presentation to my presentation that caching is quite an important factor for us. So why is that the case? First of all, we have static content. Static content doesn't change often. So somebody puts out a blog post. The blog post will probably never be updated, so it's static. Then we have performance. It is a better user experience if you get this stuff faster in the end. And the third part, which again was really important for us, is protect the downstream systems. I had many incidents in these 2.5 years, which are purely based on somebody writing a script, finding a field which is not cached because some people are evil, and then bombarding us with requests and bringing down our MongoDB instance. And we don't want this to be happen anymore. And the last point, and I think this is overlooked a lot, we want less computation. We don't want to pay a lot on Lambda, but we also don't want that the Lambda runs for static content if it doesn't change. There's no need to do that. So these are the four main points why we use caching. And before I give you too many details about how we show you some caching rules and stuff, let's first talk about edge caching and non-edge caching. Because Vercel rolled back their whole stance on edge computing a lot. So I want to show you what is actually on the edge here. So a user makes a request to our frontend. He goes to a blog post. First of all, he will hit Vercel, and Vercel is on the edge. So you get some HTML and JS files, for example. In case the page is server-side rendered, we go the first route here, and we hit the HTML page cache. This was one lesson I've learned while using Vercel is they take your whole HTML and cache it on the edge, which is pretty nice because it's super fast and you can simply use it. If this is a cache miss, then we need to go to a server and we need computation. So we need to do API requests and stuff. And this is then working not on the edge anymore. I had a podcast with Jan Choi where he explained that to me because I had it a bit wrong, because you could do this on the edge, but we actually didn't. So SSR is now not talking to MongoDB anymore, but it's talking to our API. So we hit our cache. In case we hit our cache, it's on the edge anymore, but not really on the edge because we're already in Ulysses 2. If this is a cache miss, only then we go to AWS. If you now look at client-side requests, typically pagination, for example, we do a client-side request, we directly hit our edge cache. So this is really an edge cache now. And only if it's cache miss, then we hit our API gateway. So you see, for, let's say, our hosted version, we still go a lot through Ulysses 2, but for companies, for example, who only use our APIs, they will have their cache on the edge and a much better performance. I mentioned Stellate a few times already. Stellate is a third-party provider we are using at Hashnode a lot. They give you GraphQL tools. So like I said, caching. They also give you metrics. You can see some of the metrics here on the right side, and rate limits. Or at least this is what we use. And the metrics are quite nice because since we have a kind of structured language and we have a schema, we can see all of that. And we can see which requests are used a lot, which errors are happening a lot, and what is our cache hit rate. And caching in Stellate is defined via TypeScript config. So we have a TypeScript config here. We have some rules. This is an example from our application. For example, we have the query publication user post tag, and we cache this for 24 hours and an SWR cache for 48 hours. But the nice thing is if you say, okay, we have some private data in there, so authenticated data. For example, is this post followed by me, this publication, or I have private drafts in there, I can also scope it. So I can say the scope is authenticated. And I defined the scope somewhere else and said, okay, the JWT will be decoded with the secret, and then it's scoped on this user ID. So it's not shared across all caches, it's just for this one user. And that is pretty neat, these cache rules. And one thing I wanted to mention as well, just because I love this functionality, is they also allow you to do partial query caching. That means a request comes in, a query comes in. This query, for example, we have post with post ID, title, slug, bookmarked. And these two blocks have two different cache rules. First of all, this one would be authenticated because it depends on the authenticated user if this post is bookmarked. And if this would be cached already, we have an instant cache hit. But if, for example, the title in Slug is not cached at the moment because the user just changed the title, this would be a cache miss, and this would go back to AWS, to our API. And Stellate takes care of separating this query and only sends to the backend what it needs, so it makes the query much smaller, and then putting it together and sending it back to the user. And I was a bit afraid of enabling it because enabling it is simply a Boolean like that. And I'm always a bit afraid of simply having a Boolean turn on and having something to change in your whole system. But I have to say we had 0 issues so far, so this worked out pretty good. And our cache hit rate is even better now. I haven't updated the screenshot for today, unfortunately, but it's over 90%. That means over 90% of all the requests that are coming in are cached and have super fast response rates. And Stellate even gives us an overview about the cache hit rates for different operations. So you can see on the top left, the slug catch all, which is our query for getting the blog post, has 92.5% of a cache hit rate. And this also gives us a great overview of, okay, where can we improve? Or not just improve, but what is uncached, which is a potential risk. So Stellate, I'm a fan of that, not sponsored, but I really like what they're doing because they make my life as an engineer easier. That's almost the end. We just talk about lessons learned a bit. And I separated these in GQL lessons learned and public API lessons learned. First of all, GQL learnings I had is error handling is hard. So you can see we have a link here. All these green things here are blog posts. I wrote a blog post about that because if you have an error in GraphQL, you get the HTTP code 200 OK. And that's super weird because you then have in the response an array with a key error, and then you see the errors, but it's still 200 OK. So your typical thinking about HTTP code simply doesn't work anymore. You only get 500 in other cases, like if the actual server fails. Then the second learning is stand on the shoulder of giants, and this is nothing to do with Luke's talk. This is also actually about thinking about how did other companies do it. For example, we took a lot of inspiration from Shopify. We have design guidelines with kind of discuss how we should do things and how Shopify is doing things. And that's very interesting. Then you have breaking changes. And especially once you have a mobile app out there, you have all versions of the mobile app out there always. So that's quite hard with breaking changes. So how to handle these breaking changes is still a thing in GraphQL. So this breaking change is still a breaking change, is also quite different. Then you have versioning, which in my perspective is quite easy in GraphQL because you don't version your whole API, but you only version fields. And the N+1 problem is also very interesting because since you have all of these resolvers and a user is requesting a lot of data, it often happens that you request the same data over and over and over again. And this can bring a lot of load to your database, which is not needed. So there's an approach from Facebook using data loaders. So you have a cache in between, which is also interesting, which also makes the whole thing a bit more complex. And the last point is really about the main point why we chose GraphQL is we offer data and the client can choose the data. But what actually then happens is you offer data and the client chooses to use all the data. And especially sometimes if you refactor things, maybe the queries will not be updated, even if it's not used anymore. And there's no mechanism at the moment that this will automatically, lint it, for example, and tell you, hey, you don't need this data anymore. And this is all comes down to education to say, hey, if you remove the field auth or if you don't need it anymore, please remove it from the query because the network hops are still happening. So these were the GraphQL learnings. The public API learnings are your API will be bombarded. There are bad people out there. You have a public API, so you definitely will get lots of requests and lots of DDoS. The second point is the issue is always the downstream system. 99% of my incidents are downstream system are MongoDB. So maybe also learning to think about if you should MongoDB in the future or not. Then from my perspective, we don't use subscriptions because we really can't with this architecture, or we cannot in a nice way. That's also why I say I think polling is much easier. Simply do a GET request, with a backoff rate, and poll your data in case you have a data store in between. Code will always be a mess. It doesn't matter how good your API, how good your design specs are, your API will be a mess. So try to have constant improvements in your API with every PR and keep the bar high. It's easy to make the easy thing, so try to keep the bar high and just let code in there. Caching is hard. We know that. You can't imagine how many issues we had with caching. And naming is hard. If we look at removing a publication, deleting a user, editing a post, updating a post, there are many of these names that are the same, but it's still annoying to have different of them, and changing them is not easy because you're breaking changes. So caching and naming is hard. I think that's not a new one, but everybody knows that, but I just felt that and learned that again. Here I have some resources that are really interesting. Most of them are YouTube videos, so they're really cool. If you want to dig deeper into some of these things I just told you, make sure to read them and watch them. And I think that's about it. Thank you so much.
Awesome. That was super interesting. As somebody who only ever builds REST APIs, really, to learn about another way of building things is really, really cool. So I appreciate that, Sandro.
That's
we
good.
had some good chatter about Danielle thinking Hashnode is great. There you are. Look for Hashnode.
Nice to hear that, Daniela. Thanks.
Yeah, absolutely. And then we actually had a question. One question and one other comment that I'm going to turn into a question from Richard Buggy. So thanks for the question, Richard. And it being, what would you do differently if you had to start again from scratch today? Is there any things you would change or anything you would do differently?
I thought about that as well. Maybe using AppSync, I'm not sure. Because what I love, so many things have changed with AppSync. You now have cookies in your request finally. You now have JavaScript resolvers. Again, we don't really need them. But the cool thing about AppSync is that you could have subscriptions. And even if polling is here easier, we had some parts of our architecture, for example, GitHub Backup, where we needed to add WebSockets with And then we have like DynamoDB API, WebSocket API, and there are 3 lambdas and 3 routes. So that's not super easy. What I definitely would do, I would think about and evaluating again if we should use AppSync. I think this is one major part. And then thinking about caching much more from the beginning, and also thinking about separating the code better. Because what I've meant with the point here is your code will always be a mess is also, of course, up to me, because we allow it to become a mess. So for example, having the data access and the business logic hardly separated. And yeah, I think these were some changes I would do.
It's awesome. It's actually really interesting that you mention reevaluating AppSync, because the other comment that I was going to turn into a question was, again, from Richard, saying that they're actually looking at AppSync so they can use subscriptions without needing to build a custom WebSocket implementation. So I guess that is what you're referring to, right?
Exactly. That's always the thing why AppSync is really good, is direct integrations and WebSocket and subscriptions. So that's definitely why it's good. But I would do a spike or do a prototype on that and try it out, because I think you can only have subscriptions if you have like the mutation, which is actually changing something on that object that you're listening to. So you sometimes need to create like empty mutations and stuff like that. So I would try that out, but AppSync per se is a great service.
Yeah, and I mean, GraphQL in general seems really cool. Like, I'm a big fan of things like API first design. I talk about that a little bit in event-driven architecture with like event first design. And it seems like, from what you've said, that GraphQL almost forces you into doing API first design. Like, it seems like, if I understand it right, at least, you can't use GraphQL without having an API, without having a schema first, right?
Exactly. So you need to think about your schema first before doing anything in GraphQL. But I would also say, because there was a time when Facebook, I think, launched GraphQL, that everybody used GraphQL. And this is also why I've put the first post in here, you probably don't need GraphQL, which is from the guy who built a GraphQL company, because it's actually not a silver bullet for everything. You have many learnings, and I think you see this in the presentation also. There are many learnings to have with data access, with with promises, with lots and lots of things you need to do, because the tooling is not 100% there yet. So I wouldn't just go with GraphQL by default. So if I do a side project now, or if I start with a simple project, I start with API routes. So I also understand why Hashnode did this at the beginning, because you're super fast with that. So I wouldn't start with GraphQL, but for our case, it definitely makes sense.
Yeah, absolutely. I think I've grabbed the right article, but I've just popped that in the chat. For that, you probably don't need GraphQL article. I think that's the right one. Another question that's just come in, actually, from Gary. Do you use GQL.tada? And Richard seems to think that GraphQL.tada is amazing. It sounds. I'm going to go Google it right now.
GraphQL.tada. I think I need to check that out. I hope some colleagues of mine are watching at the moment and can check it out.
Magical GraphQL query engine for TypeScript. It's a document authoring library. There we go.
Okay. Sounds interesting. I'll check it out, Richard.
Yeah, absolutely.
I'm not sure if it's an alternative to Apollo at the moment or something else, but I'll check it out.
Yeah, one other question I had, actually, and if there's any other questions for anybody else listening, just drop them in the chat before we close up. But there was some point in there when you were talking about a playground of some kind. Is that something Hashnode specific, or is that?
No, you can have a playground. Wait, I can just show it to you. Is my screen still visible? Yeah.
I've just put it back
so
up, yeah.
A playground is basically, so that's a function of the framework you use. So you either have an Apollo playground, or this is the Stellar playground now. And this is not specific to any company. So that's just basically what it is doing. It is fetching your introspection. So it's fetching your query with an introspection query. So that's like you can do a query where you get all of the introspection stuff. It's actually here. Not sure if it works. And then you can execute it here. So if you come from REST, it's basically like Swagger, or like Open API. And then you can do stuff here and execute that, and you have autocomplete your. So I can see, okay, I want the URL as well. And the great thing here is in Stellate, we can even see if this is a cache miss or cache hit, and how much of my rate limit is left. So if I execute that again, it's now a cache hit with just 100 milliseconds.
Nice. And that's actually hitting, that's not like a playground, like a sandbox. That is actually hitting like real
That's actually hitting the
real data.
our API. So that's
Very
also the API endpoint. GQL.hashnode.com is the same thing for the playground as well.
Very cool. That seems like a pretty awesome feature just to have built into a framework if you're building APIs.
Yeah, definitely.
Yeah, and we have favorite Jome saying it's really helpful, and it seems it will be. Swagger is really helpful, and it seems like this is the kind of better than Swagger, maybe. Who knows?
Yeah, kind of.
Awesome. Any other questions? Drop them in there now. Any other parting comments, Sandro? Anywhere people can find you? Anything else you want to say to finish up?
So if you want to read more about the whole thing, I had some blog posts in there that you obviously can't click in YouTube on it. So you can go to our engineering blog. So engineering.hashnode.com is our engineering blog, where I and my colleagues put out a lot of content around GraphQL, around our infrastructure, but also around EventBridge. So I've learned quite a few things from James as well. So definitely check that out. If you want to know more about me, I'm mostly active on Twitter, I would say. I think my Twitter handle here is somewhere Sandro_vol. Yeah, exactly. Thank you. And yeah, I think that's most about it. If you have any questions or if you have any comments about that, love to hear them. Just DM me on Twitter and let me know what you think.
Awesome. Well, thank you very much again, Sandro, for taking time out of your day to come and talk to us. These are my favorite kind of things to host because I learn something as well, and it's really exciting because I get to do this and it's kind of fun, and I get to meet awesome people and I get to learn things as well. So thank you again, Sandro. Thank you for everyone who's watching along, wherever you are. This will obviously all be available on YouTube after we finish up. And yeah, we've got a couple of really awesome sessions next week talking about some Gen AI use cases and gRPC in production, following on with our API month. So thank you all very much for watching. Sandro, thank you again. And we will see you all next time.
Yep. See you soon. Bye-bye.